Hello everyone, welcome back. Mr. Apple here. We're going to go over the 11.2 notes, which is finding limits with analytical methods. Okay, so first off, what is analytical methods? It's just an algebraic methods to manipulate expressions and draw conclusions. Okay, so we can kind of work with the different parts of it. Okay, so here are some of our properties of limits. So if you notice on here, if I have the limit as x approaches a of f of x equals L, and the limit as x approaches a of g of x is equal to m, well, the sum of the two of them is purely just L plus m. Same idea for the difference, right? So we have f of x is L, g of x is m. So therefore, the difference between f of x and g of x would be L minus m. So we'd figure out what the limit on each of those is and subtract the two. The product here, same idea with L and M. And this time when we multiply the two, it's purely just L times M. Cool. And our last one is the quotient. It's kind of written out for you here, but we still have L and M. So the quotient of these limits would be L over M, where we got to make sure M is not equal to 0, making that an undefined function. Cool. So let's look at a few of these. So these are ones that we know. So we know f of x is that, and g of x is 5. So when we go through this, the first one is just the sum property. So f of x is -8. And g of x is 5, so I'm going to add 5. So my info with the sum property would give me -3. Shabam. Not too bad, right? Number 2 is the product. And so I'm going to do f of x, so -8 times g of x, which is 5. And that's going to come out to be -40. We've got the quotient. Again, we want to make sure that it doesn't go to 0. And so f of x is equal to -8. G of x is 5. And that's as simplified as we can have it. We can't reduce it at all, so we're good with that. Now the last one is we just kind of have a scalar here. So we're going to do 4 times f of x, so -8 minus 2 times g of x, which is 5. So what's that? -32 minus 10. So that, thanks to the property, would give me -42. That's it. Okay. So using substitution to evaluate limits, it's very similar to Chapter 7 and a few other things you guys have already done, is we are going to replace the x with the value that x approaches. Okay, so we're just going to plug in whatever that value, whatever x approaches. So in this case, right, so for the first one, number 5 here, it says x approaches -4. So all I'm going to do is plug that value in for x. I'm going to substitute it in. So I end up with -4 plus 9, oops, would give me, in that case, would give me 5. Dunsy. Substitute this guy in right there. So we'd have 12 minus 5, or would give me 7. Not too crazy on these initial properties, right? So with the continuous whatever graphs or functions, whatever we're talking about, not too bad. You'll see in just a little bit, we got to put a little bit more work when we've got that discontinuity. Okay, so that's where limits really come in handy. Plug in the x, so -6 times 5, so -30. Cool. Keep going. This one, plug in -3, so 7 times -3 minus 4, so -21 minus 4 gives me -25. Number 9, we got a cube function here, so we've got negative 6 times 5 cubed. 5 cubed is 125 times 6, that's going to give me negative 750. Ta-da! The next one just looks crazy because there's a lot to it, but we're just going to plug the x in. Plus 2 squared minus 6 times 3 plus 5. Plug all that in, and you should come out with, after everything, should come out with 113. So double check that, make sure you can get that same value. Oh. So next one here, we've got another cube there, cube function. And so we've got 2 times 5 minus 7, that whole thing, cubed. So that would be what, 10 minus 7, so that would be 3 cubed, which would come out to be 27. Cool beans? Not too bad, we're just kind of simple math here. So square root of 4 times negative 2 squared, thankfully, under the root there. And then we got the square root of what, that would be 4 times 4, so 16 plus 5, so that would be 21. 21, square root of 21 is as simplified as we can make it, so we can't really break it down at all. All right, so number 13 definitely makes me nervous because of my denominator there, but I'm going to plug it in, make sure everything works. So 1 cubed minus 3 times 1 squared plus 7 over 2 times 1 minus 5. The first thing I'm going to check is the denominator, make sure that we don't have a 0 there, which we don't. It comes out to be negative 3. Okay, and so then the numerator, we've got 1 minus 3, so negative 2 plus 7, so 5. You can keep it like that. I kind of like having the negative out in front. So negative 5/3. So we lucked out on there. Our denominator didn't go to 0. So here, there's nothing to plug into. So what this means is this is going to be consistent for whatever x value you plug in. So in this case, since there's nowhere to plug in, our final answer is just 3. Cool. It's whatever that limit comes to. Now this one is whenever one of our properties, whenever these guys match, it's whatever it approaches, right? So when I plug x into x, it's whatever that value approaches. So in this case, negative pi. Cool. Now this one, of course, you could graph it, but we want to try to work away from having to graph it. So if you look at these inequalities, so this is less than, so this is the left side, whereas this one down here is the right side of the graph. If you remember from 11.1, in order for my limit over here in C to exist, the left and the right have to match each other. So if I plug in 2, in this case, the left side, so the top equation, all I do is plug in 2, so 2 squared plus 5, so that would equal 9. Now for B, we're coming from the right-hand side, so I'm going to use the bottom equation there and just plug it in, so 3 times 2 plus 1, so that would be 7. Now for this, I would want the left and the right to match each other for C, but unfortunately, they don't match each other, so this would be a jump function, right? So there'd be that discontinuity. So this guy does not exist, unfortunately. Cool? Because they don't match. They don't meet up in the same spot. Okay. All right, so now this gets into a little bit more exciting calculations. So when we're talking about stuff that is discontinuous, has points of discontinuity. So limits can exist at some discontinuity, okay, aka holes, as long as they approach the same spot, the same y. When substituting results in 0 over 0, this indicates a hole in the graph. Rewrite the expression with one of the methods below, factor and reduce, or rationalize the numerator. Okay, so on this first one, we're looking at number 17 here. You always want to try, like pre-number 17, so 1 through 16, you always want to try to plug in, right? But if I notice right away, if I plug in there, I get a denominator of 0, okay, which makes me unhappy. And so that tells me I need to do something. Well, I noticed that I can factor the numerator. So if I factor the numerator, I've got x minus 3, x plus 2 over x minus 3. Now what I could do is I can cancel these out, those common terms, and now what I'm left with is the limit as x approaches 3 of x plus 2. Once I get this, this is like the first 16 that we did. You just purely plug it in. So this would be 3 plus 2, which is 5. Okay, so that means there would be a hole at x is equal to 3, but they came to a similar y value. So we actually do have the value there. Okay, so again on this one, you plug in 0. This one's obvious because if you plug in 0 for x, that denominator goes to 0, and we're not happy with it. Okay, so most of your high school math career, when we hear rationalizing, it's to get that root out of the denominator, right? Well, we kind of lied to you. A lot of the stuff that you guys will be doing in calc is you're going to rationalize the numerator, okay? But the nice thing is you know how to do it now, right? So you're going to do amazing. So we keep this guy, multiply it by its conjugate, so multiply it by a plus 2 on top and bottom. Okay. And so as you go through here, technically we need to keep these limits on each one. So we rationalize the first one, right? Or sorry, multiply it out. So that's nice when you got the root and a root. If they match each other, it's just what's underneath the root. And since it's a conjugate, all I need to do is the first and the last terms. Now, yes, I'm kind of tempted to distribute with the denominator, but just because I've done this one a few times, we want to kind of keep the denominator separate, and you'll see why in just a second. So as I simplify this out, x goes to 0. You notice the 4's cancel, and I'm left with x over x times this whole thing. Cool. And so it's nice now that hopefully you can see, since I kept that x outside, it's a lot easier to see that I can cancel these, one on top and one on bottom. Now remember, if you cancel everything on the top, or the bottom in this case, you're just left with the 1. So then in the denominator, I have the square root of 4 plus x plus 2. Okay. And so when I actually calculate it out, I'm going to put 0 in for x. And so I'm going to come up here to the top. I should get 1 over square root of 4 plus 0 plus 2. So what we say is when you take the limit and I actually plug it in, notice how I'm not writing the limit anymore here. So once you actually take the limit and plug this, whatever x is approaching, once you plug that in, you get rid of the limit itself. So we get 1 over the square root of 4 plus 2, which is 1 over 2 plus 2, which is 1/4. And that's it. Okay, so definitely some work there, but once you start seeing this rationalizing, it's pretty repetitive in that case. Okay. So the nice thing about number 19 is if you look, I don't really need to factor or do much, right? So again, I would always check to make sure I could plug in, but right away I notice if I plug 0 into the denominator, it doesn't work out for me, okay? But I do notice everyone shares an x. So see ya one of them, right? So then what I'm left with is the limit as x approaches 0 of 7x minus 3. Now this is really nice. This is just a linear function, but that's continuous. I can just plug it in. So this is going to be 7 times 0 minus 3. So my final answer is going to be -3. Cool beans? Cool. And then let's check out this one. So if I plugged it in, again, 9 minus 9 goes to 0, doesn't work out. I've got to figure out something. So me personally, there's no one way to do it. I always see if I can factor first, because as much as I do love to rationalize, I try to factor first, okay? And so unfortunately here, there's nothing to factor in the numerator or denominator, so that means I need to rationalize. So I'm going to multiply top and bottom by the conjugate. Oops, that's an x, not a 3. Uh-oh, go away, go away. Okay. It's mad at me right now. So I'm going to bring it over here, but multiply it by the conjugate, top and bottom. And so in the numerator, as x approaches 9, do the first, so that turns out to be an x, and do the last, that gives me 9. So again, my recommendation is maybe don't distribute in, because right now I have the denominator of x minus 9 times this conjugate. And so if you notice, this guy cancels with this one, and so I end up with the limit as x approaches 9 of 1 over the square root of x plus 3. Now I can plug this in, and so I end up, once I plug it in, the limit part of it goes away, and keep solving it. 1, 3 plus 3, which is 6. So 1/6 on that guy. Cool. So a couple one factor, a couple rationalizing, and one just simplifying on number 19 there. Okay. Nice. Now, number 21, we're going to go over these, a few examples of this. So this guy's known as the definition of a limit. And so you'll see later on in chapter 11, we work with something a little bit different. But this is how we, without saying too much, this is how we're going to go through and figure out that what's called the derivative of it. And so all you're going to do is you're going to take the limit as h approaches 0 of any of your functions here. And so take it one step at a time, okay? So there's a lot of writing, but a lot of it's repetitive, okay? So if I gave you something like f of 3, right? So you would know that x would equal 3. Wherever you saw an x, you would plug in a 3, right? So I'm going to go through and solve that first. So all I'm going to do is wherever I see an x, I'm going to replace it with x plus h. So my limit as h approaches 0, again, I'm going to do -2, plug in x plus h where I see the x, plus 5. So that right there is that part right there. Now I'm going to go back, and I'm going to do just purely minus f of x. So all that means is I'm going to do minus whatever the function is. I'm not changing it at all. I'm just plugging it in. So this is the minus f of x part of it. And then the last one is we don't do anything. Whoop. We don't do anything with it. We just divide it by h. So all that divided by h. Okay, and so that's where everything comes from. And so wherever you see an x, you're going to you do two things. You plug in x plus h, and then really, if you notice, what's going to happen if I do the negative on the outside, I'm just going to change the sign of everything in the function. So now you need to just clean it up. So the limit as h approaches 0, this is going to be -2, right? I need to write this 2 times, x plus h, and FOIL it out. Oops. If you need a little extra time, you can pause it and FOIL it out yourself, but this should come out to be x squared plus 2hx plus h squared. Whenever I have a bunch of variables, as much as I can, I try to put them in alphabetical order. Okay, as long as you put everybody in alphabetical order, it's a lot easier to compare and contrast everyone. Okay, then we have what, 2 plus 2x squared minus 5. Still all over h. Now I'm going to do one more step and distribute that -2 into everyone. So I have -2x squared minus 4hx minus 2h squared, and then I didn't do anything here. what you're going to find out in this next step is the stuff that's highlighted in blue over here, it will always cancel out with the rest of the function. So if you notice, this guy is going to cancel out with this one, and this one cancels out with, oh, I forgot. That's a good check. So I forgot this guy right here somewhere in the mix. So I forgot right there. Sorry about that. So there should be a +5 right there. Sorry about that. And again, so this should be a +5 right there. So that's a good check. I knew they were supposed to cancel, so this guy's going to cancel with that one. And so everyone that's left over should have an h involved. So the limit as x, holy smokes, making a few mistakes here. The limit as h approaches 0 of, I'm left with negative 4hx minus 2h squared. Let me do a quick check. I think that's everything. All over h. Now, if you notice, they all have h's in common. So now what I could do is cancel, 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 like we did before, because if I plugged in 0 right there, so this is very similar to, what was that, number 19? If I plug in 0, it goes undefined. So now I have the limit as h approaches 0, because I haven't plugged it in yet. I just checked it here and I was like, oh, that doesn't work. So I had to simplify a little bit. So negative 4x minus 2h. Now I can, wherever I see an h, I'm going to replace it. Be careful not to replace the x. I'm replacing h because it says as h goes to 0. So since I plugged it in, now I have negative 4x minus 2 times 0. In this case, I'm going to be left with negative 4x. And again, as the chapter goes on, we'll describe a little bit more what exactly this is. Okay? But that's the process right there. So we'll do a few more of these guys. I have, 3 more in this section. And so we'll go through this process right here. So we're going to do the limit as h approaches 0. Plug this into this equation here. So I've got square root of x plus h. And then what I'm going to do is I'm going to do the minus f of x. So minus f of x. And this is all over h. Now, if you do a quick, super duper quick check, if I plug in, I can't combine anything in the numerator because they're a little bit different. If I plug in 0 here, it makes my denominator go to 0. So this is one that would be similar to like number 18 or 20, where I need to rationalize the numerator. Believe it or not, it looks harder than it really is, in my opinion, because, again, when you get that idea of conjugates, all you have to do is the first and last term. And then we're not really going to, at least initially, really ever going to distribute in that denominator. We're going to keep it separated unless we need to distribute it in. Okay? And so the numerator is this guy and this one, so x plus h, and then minus that all over h, and then the rest of this, x plus h plus square root of x. And if you notice, we'll do a bunch of things because you guys are geniuses. Or cancel that, right, because those go away. And then we can reduce this one and this one. So I'm left with the limit as h approaches 0 of 1 over the stuff that's in the parentheses, square root of x plus h plus square root of x. Now my next step is I'm going to plug in h of 0. Okay, so I'm going to plug in h of 0 in this case. And I end up with 1 over square root of x plus 0, so just square root of x plus square root of x. So this comes out to be 1 over 2 square root of x. And this is okay. Rationalize. So I'm okay with this as an answer. You're like, what the heck? I know, but things change. Cool, so 23, I'm gonna go through it. It looks a little bit different, but the process is exactly the same. So I'm gonna take the limit as h goes to 0. So wherever, it doesn't matter how many x's you have for this first step with the x plus h, you just plug it in. So x plus h squared minus 4x plus h. Now the second part of it is you're just gonna take the same exact function, but change the signs. And all of this is going to be over h. So that's the setup there. And then from here, what you're going to do is just go through and clean everything up and cancel. Again, you could probably take a wild guess that these two in green are going to cancel with somebody. So if I make another mistake, we can check that. So again, you guys are geniuses, so I'm going to do this together. I'm going to FOIL and distribute in the two. So I should get x squared. Right, so x squared from those first x times x, so I have 2x squared, and then I should have 2hx. This is a very common thing that we get because of that squared idea. So 4hx, because I distributed in the 2, and then this is h squared, so 2h squared. Now distribute in the negative 4 to both of them, so negative 4x minus 4h, and then we have these 2 at the end. All over h. Now go through, see what cancels. So this guy should cancel with this guy, and this guy should cancel with that one. So now I'm left with the limit as h approaches 0 of 4hx plus 2h squared minus 4h all over h. Now they all have an h in common, so we cancel those out. And so now the limit as h approaches 0 of 4x plus 2h minus 4, and then plug it in. Okay, so then we have 4x plus 2 times 0 minus 4. So my final thing after I've done all the substituting is 4x minus 4. Cool. All right, last one here, last one. So let's cruise through this. So the limit as h approaches 0. So plug, yes, it looks weird, but it's just the x is there. So x plus h, x plus h plus 5. And then here minus whatever f of x is, or I should say the opposite, all over h. Now this is one should kind of scream at you. There's no factoring. I can't clean it up. This is very similar to maybe like a 19 or 22. I can't plug in the 0. It goes undefined. So I got to multiply by its conjugate and rationalize it, right? So x plus h plus 5 plus x plus 5 on top and bottom. X plus h plus 5 plus x plus 5. Okay. Now multiply the conjugates. So I end up with limit as h approaches 0 of x plus h plus 5 minus. Now this is where we've got to be careful because it's minus the entire thing. So it's minus x plus 5. Okay, so very common mistake to do a minus x plus 5, but forget to distribute in the negative. So cleaning it up, totally forgot this ginormous thing in the bottom. X plus h plus 5 plus x plus 5. Cool. Okay, so the limit as h approaches 0. So if you notice, I've got x minus x, so those guys will go away. And I've got 5 minus 5, so those go away. And then again, very common thing, we got an h on the top and an h on the bottom. So I know I kind of did a lot in one step right there, but if you notice, the x's cancel, the 5's cancel, and then the h, we have one on top and the bottom, so we can reduce those. So I'm left with 1 in the numerator and all of this crazy stuff in the denominator. 5 plus x plus 5. And so my last thing is I'm going to plug an h of 0 into h. So I should get 1 over square root of x plus 5 plus square root of x plus 5. Now it looks weird, but I have 2 of them, so I could just say 1 over 2 square root of x plus 5 and call it a day. Awesome. I hope you guys enjoyed that. Please tell a friend, and we'll see you next time.